In this lesson, we're going to talk about parallels and transversals. So first, we are going to start with some definitions or vocabulary. The first thing we're going to talk about is alternate exterior angles, all right? And then we're going to look at alternate interior angles. After that, we're going to look at corresponding angles, and then we're going to look at same side interior angles. And all four of these angles are angles that we're going to prove based upon a transversal, which is a line that intersects two or more lines in a plane. I would read all the definitions to you, but it will actually make more sense if I read the definition with the example up. Okay, the first thing that we want to talk about is the transversal. What is a transversal? A transversal intersects two lines. In this case, we're going to be looking at a transversal intersecting two parallel lines. So if you look here in purple, okay, we've got my two parallel lines, and then you've got the transversal that is intersecting it. And if you notice, the transversal creates all of these little angles here. And these are what we're going to be looking at, is all these little angles that transversal makes whenever it cuts those parallel lines. The first thing we're going to be looking at is the corresponding angles. Okay, corresponding angles are angles that lie on the same part of the line of the parallel lines and the transversal. So they kind of match up. So if you look here, A and E are both lying in the same spot. On the top parallel line, A is on top and to the left of the transversal. On the bottom parallel line, E is also on top but to the left of the transversal as well. So A and E are corresponding angles. And that means that they're congruent, okay? And remember, congruent means that they are the same or that they are equal, all right? B and F are also corresponding angles. If you notice, on the top parallel line, B is on top and to the right of the transversal. F is on top and to the right of the transversal. So these two are also corresponding. C and G are corresponding, and D and H are corresponding. Alternate exterior angles are angles that are on opposite sides. So when we say alternate, we're thinking of opposite, okay? Opposite sides of the transversal. So look at A and H. A is on the left-hand side of the transversal and H is on the right-hand side. Okay, they're also on the exterior. Okay, when we're talking about the exterior, we're talking about the parallel lines. So this would be inside, my interior. So all of these angles here are on the exterior. So A and H are opposite, alternate, and on the outside, exterior. So A and H are congruent or the same. B and G are also on the opposite sides, alternate, and on the outside, on the exterior. So B and G are congruent. Alternate interior angles is the exact same thing, only now we're looking at the inside of those parallel lines. So here, earlier we were looking at the outside. Now we're going to look at the inside, okay? C and F are both on the inside, okay, interior, and they're on opposite sides. C is on the left, F is on the right. So these two are congruent. D and E are on the inside and on opposite sides. D is to the right, E is to the left. They're both on the inside, so those are congruent. Now we're going to look at same side interior angles, all right? So again, interior, here's the exterior, so we're looking on the inside, all right? And now we're looking at the same side, though. Here, C and E are on the same side of the transversal. Now, our last three rules that we looked at, we're talking about congruent angles. All of those that we just looked at are congruent. The same side interior angles says that these two angles are supplementary, which means that they add up to 180 degrees. And usually if you look at your transversal, this makes sense because if you look at this angle, it kind of looks like an acute angle, right? It's a little less than 90, and then this one looks bigger than 90, so we know it's obtuse. So if we just look at the picture, and again, you can't always go off the picture, but if you just look at the picture, you can kind of see that these do not look equal, so they're not congruent. They are supplementary. All right, D and F are also supplementary, meaning they add up to 180 degrees. Okay, let's look at some examples here. All right, DE is parallel. All right, that's what, when you see these two lines right next to each other, that means parallel. All right, DE is parallel to BC. All right, so we're looking at DE and we're looking at BC. Now, when I look at transversals and parallel lines, sometimes it helps me if I extend my line out a little bit so I can kind of see what I'm looking at. That's not always helpful to everybody, but it's helpful to some people. And then we're looking at this transversal and we're looking at this transversal here. So if we know that the measure of angle 3 is 52 degrees, this is wanting to know what the measure of angle 6 is. So right here, we're looking at this transversal right here, okay? So if we look at angle 3, all right, let's just talk about where it's at, okay? It's on the top parallel line, and it's to the left of the transversal, okay? So top of the parallel line, left of the transversal. If we look at this bottom line right here, the bottom one, angle 6 is also on top and to the left. So these angles are matching up. They're the same. So this is what we would call corresponding angles. So angle 6 also measures 52 degrees. On this one, we are going to find the angles for X, Y, and Z. Okay, so first of all, here is my parallel lines, okay, and then here's my transversal. All right, so first, let's look at Z here. If we have 75, right, it's on the inside and to the right of the transversal. If we look at Z, it's to the left, but also inside. So these two angles are alternate interior angles, which means that they are congruent. Okay, so if they're congruent, then we know that Z equals 75 degrees. Okay, now if we look at Y here, okay, we know that Z is 75 degrees, all right? This is using a definition that we've already learned, okay? Z and Y are a linear pair, right? They're adjacent to each other, and they form a straight line, so they're going to equal 180 degrees. So all we're going to do to find this one is we're going to take 180 and we're going to subtract 75 from it. And that's going to give us 105 degrees. So we know Y is 105 degrees. Okay. Now, if we look at X, okay, we also can do the same thing that we just did, right? X is forms a linear pair with the 75 degrees right here. So we also know that X is going to be 105 degrees. Now, if we didn't have this 75 degrees right here, if we also look at X and Y, right, these X and Y are on the outside but opposite sides of the transversal. So X and Y are alternate exterior angles, meaning they're congruent. So they should both be 105 degrees. So now we know that that is correct. On this one, we are going to determine whether the pair of angles are corresponding, alternate interior, alternate exterior, or same side interior. Okay, so let's look at angle 4 and angle 7. All right, now we are assuming that these two lines are parallel, okay, because we have these little arrows here showing us they're parallel. So if we look at 4 and 7, all right, they're on the inside of the parallel lines. Okay, everybody see that? They're on the inside. They're also on the same side of the transversal, okay? So these are actually going to be same side interior angles. All right, now let's look at angle 1 and angle 5. All right, angle 1, okay, let's talk about where it's at. It's on the top of the parallel line, of the top one, okay, on top of the top one and to the right. 5 is also on top of the bottom one and to the right. So these angles are in the same spot on two different lines. So remember, when they're in the same spot and they match up, we call those corresponding angles. Angle 2 and angle 7, all right? If we look at angle 2 and angle 7, they're both on the inside of the parallel lines. So we know that they're both interior angles. And if we look at where they're at on the transversal, they're on opposite sides. So we know that these are alternate interior angles. And then if we look at angle 3 and angle 6, right, these are both on the outside of the parallel lines. And they're on opposite sides of the transversal. So these would be alternate exterior angles. And this one right here, this one can look a little bit complicated. The best way to solve anything, right? Have you ever heard the how do you eat an elephant? One bite at a time. When you see a problem like this, that's all you need to do. Don't get overwhelmed by looking at all of the different angles that you have to find. Just start with what you know and then go from there. All right, so first of all, let's look at what our problem gives us, okay? It says that BE is parallel to FH, and the measure of angle M is 83 degrees, and the measure of angle S is 62 degrees. Okay, so the first one that it asks us for is the measure of angle G, right, which is this one right here. Now this one we know, this one doesn't even have anything to do with the parallel lines. All we have to know right here is that it's a vertical angle with angle M. So we know that a vertical angle is the same, right? They're congruent. So angle G is going to be 83 degrees, okay? Now, if we move on, okay, and look at angle K right here, all right, if we look at angle K, what we are looking for is either a corresponding angle, an alternate interior angle, something that it's going to match up with. And it's going to need to be on this transversal right here, okay? Because angles can only be congruent along the same line of the transversal when we're proving, okay? Until we prove that one angle is equal to another, we can only look at one transversal, okay? So if we look here at angle M, we have almost what we need, but in order for it to be corresponding to K, we need also U. M plus U is going to be corresponding to K. All right, now if we look at angle S right here, okay, it's to the right of the transversal, but on top of the parallel line, okay? And this one is inside, but to the left, okay? So on this one, probably what is best to do is look for a different one that we can get before we go on to angle K. Now we can go ahead and get it, but it'll be a little bit easier if we can find something else. Like here, we know that K and W, right, are both same side interior angles, so they have to be supplementary. Now if we look for W, what do we notice right here? That W is vertical to S, so we know that W is 62 degrees, okay? Now we can go and find angle K because we know that these two have to be supplementary. So all we have to do for angle K is take 180 minus 62, and that's going to give us 118 degrees. So we know that angle K is 118 degrees, okay? Now for angle N, all right, we could do two things right here, right? K and N form a linear pair, right? So they're adjacent. That means they're supplementary. So we could take 180 minus 118, all right? Or we could look at What else we know here? If you look at W, right, N and W are both on opposite sides of the transversal, and they're both inside the parallel lines. So N and W are alternate interior angles. So we know that angle N is 62 degrees. And we can check that by adding up 62 and 118. 62 plus 118 is 180. So we know that that's correct, that it would be 62 degrees. Okay. Now, angle U here, okay, angle U, if you notice, is forming more of a triangle. So this one, we're not really going to be able to use any of the alternate interior, alternate exterior. If we look here, we have angle M and angle S, right, 83 and 62. So we know that 83 plus 62 plus the measure of angle U has to equal 180. Okay, so 83 plus 62 plus the measure of angle U has to equal 180. Okay, so that's going to give us 83 plus 62 is 145 plus the measure of angle U needs to equal 180. Okay, so now we know the measure of angle U is going to equal 35 degrees. So we can say U is 35 degrees. The measure of angle V, okay, and again, we're just going to look for some angles that are similar here, okay. The measure of angle V, if we look at this bottom parallel line, it's on top of the parallel line and it's to the left of the transversal. Okay, if we continue up this transversal, let's look at M here. M is on top and also to the left of the transversal, so we know that V can equal 83 degrees because M and V are corresponding angles. And now we also know that angle W, okay, remember earlier we already found angle W because we need to find angle K. So all we have to do with this one is just say 62 degrees because we knew that it was vertical to angle S. All right, last one. I know I kind of wanted to go over a proof. I know for a lot of you guys, you really struggle with proofs, so I'm going to show you how you would go about solving this one, okay? In this one, you're given that AB is parallel to DC. So these two lines right here are parallel, okay? And then it gives you EF is parallel to GH. So we know these two lines are parallel. Then it says AG is parallel to LK, so these two lines are parallel, and that NJ is parallel to BH. So we know that these two lines are parallel. And what we want to do is prove that angle 1 is congruent to angle 16. Okay, so A right here, okay, is all of the given information, so what we would write right here is given. Okay, and on this one, it's already, all of your steps are already given for you, your statements. All you have to do is give the reason. So here it says that angle 1 is congruent to angle 12. All right, so here we're talking about these two lines being parallel. Okay, so angle 1 and angle 12, okay, are going to be alternate exterior angles. Okay, then it gives us angle 12 is congruent to angle 16. Okay, and we know that angle 12 is congruent to angle 16 because if here we look, they are going to be corresponding angles, right? Because 12 is below and it's to the right of the transversal, and 16 is also below and to the right of the transversal. So it's going to be corresponding angles. So now we know that angle 1 is congruent to angle 12, and we know 12 is congruent to angle 16, so we know that angle 1 is congruent to angle 16 because of the transitive property. Okay, and remember the transitive property says that if A, in this case angle 1, equals B, which is angle 2, and angle 12, And B, which is angle 12, equals C, in this case would be angle 16, we know that A equals C, which is angle 1 is equal to angle 16. And then you have proved your statement. And that is it. In the next lesson, we will talk about the converse of parallel lines.